Alright, here we go. We'll do 11 and 13 on this one. A poll conducted July 2010. Tells you how old the book is, I suppose. A random sample of 2163 adults was asked, when you see an ad emphasizing Made in America, you're more likely to buy it, less likely to buy it, neither more nor less likely to buy it. The results of the survey are presented side by side bar graph. This is actually really interesting, and you'll see a lot of this. Most of the data that's taken from the book is real data. Every now and then they'll tweak it if they're trying to make a point, but for the most part it's legitimate. So more likely is the blue, if you hear it, less likely is the green, and neither, doesn't matter, is the orange color. So if you just look at it, the younger generation more likely to buy it if it's not made in America, and the blue, you're more likely to buy it if it's made in America. So pretty interesting. You can make some assumptions as to why that might be. Probably talk about it in class a little bit. What proportion of 18 to 34-year-old respondents are more likely to buy it when it's made in America? That's going to be about, right here, 43%. So this will be 43%. What proportion of 35 to 44 are more likely to buy it when made in America? That's going to be about 61%. Which age group has the greatest proportion who are more likely to buy when made in America? That's going to be the 55 plus group. Which age group has a majority of respondents who are less likely to buy when made in America? Less likely to buy. Wait, let me reread that. Which age group has a majority of respondents who are less likely to buy when made in America? Okay, sorry about that. Had to take care of something. Which age group has a majority of respondents who are less likely to buy when made in America? Well, that's going to be these guys, isn't it? Oops, let me circle that. Majority of these people, if it's made in America, are going to go elsewhere, right? They're slightly over a majority. Over 50% are going to go somewhere else. So this is going to be the 18 to 34. They grew up with foreign products being well made, right? Back in the 80s, if you wanted to buy in 90s and 2000s, foreign cars were well made. Before that, foreign cars were not well made, for example. Okay, what is the apparent association between age and likelihood to buy when made in America? Well, it's pretty clear. The older people are, the more likely they are to buy American made. Okay, and then conversely, same thing. The younger ages are more willing to buy non-American made products. Okay, I think it really depends on what the product is, to be honest. So you got to be careful making big generalizations, but there you have it. All right. Let's see. College survey. Now survey conducted by Centers for Disease Control. Health risk behaviors among college students. Students were asked, how often do you wear a seatbelt when riding in a car driven by someone else? And here we go. Never, rarely, sometimes, most of the time, always. That's an amazing to me that you're putting your life in someone else's hands and there's that many people, but that's another story or another discussion. Construct a relative frequency distribution. Well, for me to do a relative frequency distribution, I have to know the total. So if I do the total, that's going to be, I believe it's 4776. I added those up earlier. So the total's 4776. So to do a relative frequency distribution, I have to find the percentages. So I've got my calculator here, 125 divided by 4776. And I'm going to round to the nearest whole percent. So it's 2.6% or 3%. And so I got that by doing 125 divided by 4776. So then I'll do 324. I won't do them all like this. I'll just show you one more. So I got 324 divided by 4776. And that's 6.7 or 7%. And then 552 divided by 4776. 11.6 or 12%. And then 1257. 26%. And 2518. 53%. And let's just add those up just to see. 53 plus 26 plus 12 plus 7 plus 3. And that's actually 101%. And again, that's a rounding thing. We mentioned this in class. Because if I round up enough times, then I'm going to end up getting an extra percentage here. Okay, on these. So if I do 3.6, that rounds up to 4. 4.7 rounds up to 5, for instance, and so forth. So I'm actually adding percentage points when I round, when if I kept on adding all of these decimals up, I wouldn't get that extra point. So that's the reason for that, and that's okay. Don't worry about that. It's no problem as long as you're doing the calculations correctly. It's nothing to worry about. So relative frequency distribution here. So I've got, let's see, seatbelt use when a passenger. Make sure you label everything. This is percents. And we've got never, rarely, sometimes, most of the time, and always. And then over here, I usually just start at 100 and then just start splitting them in half. Oops. 50, 25, that's going to be 12.5, and so forth. So we go 3 for never, it's going to be a little bump there. Rarely 7, sometimes it's 12, just a little below there. 26 is most, and 53. Oops. Whoa. Sorry about that. 53. Alright. There we go on that one. Just make it a little smaller here. Okay, what percent answered always? There you go, 53%. What percentage answered never or rarely? 3 and 7. Construct a frequency bar graph. Okay, I did D. This is D. A relative frequency distribution is what we did right here. That's the distribution or the values. I kind of jumped ahead a little bit because I got a little excited about drawing the graph. So we did, wow, see, I'm actually really going crazy. We did a relative frequency bar graph. That's what we did here, okay, because these are percents. A frequency bar graph would be ones with counts. Seatbelt use. Okay, so this up here is is a relative frequency bar graph. And then this down here would be a frequency bar graph. So we have never, rarely, sometimes, most of the time, always. And here would be counts. And the highest count is 2,500 approximately. So I'm going to make this like, I'm going to go big now, okay? So you can see it better. We'll make this 2,500. Then we go to 1,200. Then we go to 750. Then we go to, what's that? Half of 750. 375. And all the way down. So never would be 125. So that's just going to be a little bit small down there. So that's 125. Rarely is 324. 552. 1257. A little bit over there. That should be 1250. Sorry, I don't know if that came. 1257. And then 2518. So these are your counts. Okay. Oops. 2518. Sorry for going so fast and doing this all out of order. Okay, so there's your frequency bar chart here, and this is your relative frequency bar chart up here. Okay, so we're going to do a pie chart in a second here. I'm going to do G. Suppose that a representative from the Centers for Disease Control says that 52.7% of all college students always wear a seatbelt, descriptive or inferential. Well, since they're making a statement about all college students, as we talked about the first day, and I mentioned in the last video if you saw that, since they're making a statement about all college students, that's an inference statement. An inference statement is a statement about the population. G, statement about the population is an inferential statement. In other words, you're using your sample to say, hey, I'm going to generalize this because it's a good representative sample of the population. So we need to do a pie chart. So I'm going to move this over here. In a pie chart, we could use these percents. So let's see if I can do a reasonably good circle here. And I've got my percents here, and I've got slightly more than 50%. I'm going to do from the biggest over, so 50% is going to be just a little bit here, so this is always at 53%. Okay, so this is seatbelt use. When a passenger. Okay, now most 26, so see I know that's just a little bit more than 25%, and remember we said 25% is this 90-degree angle right here. So I'm going to go just a little bit bigger than that. And say this is most of the time. 26%. Now I got 12%. 12% is how many degrees? So remember we did this? 12% of 360 degrees. So I'm going to do that over here. 360 times 12. 43 degrees, so good. That's just over, just under 45. So if I go here, and again I'm going to go up, there's my 90, so 45 is like halfway. So I'm going to go right about there. Now I'm just trying to be as close as I can, so this is sometimes. And I get 12%. Erase that guy. And then I get 7 and 3%. So 7 times 360. 7% is 0.07 times 360 is 25 degrees. So 7%, 0.07 times 360. Now, this I'm going to do this to make this as accurate as possible. Is 25 degrees. And I've got 3%, the never, which is way over here, right? 0.03 times 360. Now I know this is going to be slightly less than half of that. 0.03 times 360. So I'm trying not to do this blindly. I'm trying to keep on thinking about what I'm doing here. 10.9% or 11%. So I'm going to split this and make this one, this was 11, a little more than twice as big as that guy. And we'll call this rarely at 7%, and this one never at 3%. Okay, so there's our pie chart. Seatbelt use when you're a passenger. All right, there you have it.